So I'm Leung. I'm a Senior Director of Product Management for Oracle Cloud Infrastructure, and I'm going to talk a little bit about some use cases on the other end of the spectrum. Earlier, I talked about use cases and case studies around enterprise applications. Now I'm going to talk about some of the performance applications, high-performance applications, and cloud-native applications that are running on our cloud as well. So one of the things that's true, I think Stephen was mentioning this, is Oracle has a lot of products. So we also have a lot of different services. We have something called Oracle Data Cloud, which is this massive advertising targeting system, right? So we have a number of very interesting customers of Data Cloud, who I won't mention, but they use them, for example, to target travel advertising, right? If you book a hotel and you get an ad for another hotel, it's probably data coming out of Data Cloud that's actually being served up. So this is an acquisition that Oracle made, I think, 4 or 5 years ago. And this stack was actually, there's very little Oracle in this stack, but it's massive scale, right? So literally billions of API calls. And I think it's a good example, even though it's an internal or it's an Oracle property. Guess what? There's plenty of Oracle properties and acquisitions that don't use all Oracle technologies, right? So to get them on board and using our cloud, I think was a great use case for us. And what was cool about it is now you have this, I'll call it a two-tier application. One is they have this massive ingest engine where they literally have over 1,000 of these giant bare metal servers that ingest all the API calls. And on the back end, they have an equally large Hadoop farm, right? Where it's petabytes and petabytes of data in order to they'll do quick turnaround on some targeting requests. Otherwise, they'll need to do a mining of historical data using the Hadoop cluster. So this is an example of an application which actually prefers or consumes bare metal versus virtualized environments. It actually consumes local storage. The architecture prefers high-speed local storage. And they were able to get a significant performance advantage over their previous deployment, which was a hosted environment, also bare metal servers, but we were able to give them much more performance. And how many people know what the Hadoop architecture looks like or have any experience with it? So, there's one concept in Hadoop around affinity, node affinity, right? And they actually had that deployment on-prem, where they literally ran out of room to continue scaling because they still required node affinity within a single row of racks, right? They literally could not increase the size of the cluster anymore. When they deployed in our architecture, because of that, all the things I talked about earlier, the non-blocking, the no oversubscription, the low latency between nodes within an AD as well as across availability domains, they actually were able to basically, they weren't limited by that Hadoop concept any longer. They were actually able to distribute their master nodes as well as the worker nodes across different availability domains, which totally allowed them to scale without limitations. Right? And it is a very cyclical application based on shopping patterns and whatnot. So they have very big peaks as well as valleys. So that ability to scale was a big benefit as well, in addition to the increased performance. So FireEye is one of our customers. So as I said earlier, there's actually literally thousands, if not tens of thousands of software companies that are in a cloud transition as well, right? As they move their on-premises businesses or applications into the cloud, they're looking for partners. They're looking for providers that can help them do provide their services as a cloud service. So FireEye actually has a number of different SaaS properties, including email security. And the email security application, I actually have an open world session with FireEye next week, is interesting because it has essentially a simulation engine inside where they quickly construct VM environments, KVM-based environments, and tear them down. And these simulated environments are essentially like clients or hosts, where they attack the clients with various tests in order to provide then the security response for the SaaS application. So this is another very, very high performance type of application where they have a custom KVM stack and they're constantly spinning up and tearing down environments, thousands of environments per minute. And that serves up the data for the SaaS service. Okay, so their intent is actually to run a number of these different end-facing SaaS services, leveraging this core engine. This is another customer of ours that's leveraging high-performance characteristics. So we have a number of rendering companies as customers. Okay, so this is another perfect kind of cloud use case. Very high performance requirements for 3D rendering. They're a user of both our x86 as well as GPU instances. And it's very cyclical. It's dependent on a project. They happen to serve lots of cartoon studios and animation studios in Europe, okay? Where, again, it'll be a big job for a day, a week, whatever, and then they shut everything down, okay? So they are able, because, Adil wasn't able to show this, because they're able to spin up a bare metal instance in 2 minutes or 10 or 100 in minutes, they're able to satisfy the workload, pass on whatever savings they can to the customer, and then shut the whole thing down when they're done with their project.
So usually for other clouds, the instances are charged by the minute or by the hour. What happens with the bare metal instances?
Per hour.
Per hour.
Yep.
Okay, very good.
So, same cost structure, same price structure as VMs. Yeah, so again, that's the difference between maybe like a classic. There's a number of differences. I think people last time got a little confused between, well, are you like a hoster? A hoster will not give you that. A hoster will not be able to provision hundreds or thousands of these instances like that, right? Using API calls or an orchestration engine. And they will also not be able to establish a network for all those machines, right? We do all of that as code. So these types of customers, whether it's inside of a company or a provider like these guys, can take great advantage of this type of capability. And again, we'll have some interesting stuff, more interesting stuff coming in this particular category of applications. And again, I think, just to be super frank, I think that our target very much is enterprises. But when we get a brand new customer or a startup or a brand new company, that's awesome too, right? And eventually we will give them, very soon, we'll give them all the tools they would expect out of a cloud, right? But we're still working on some of those things. With some customers though, savvy customers like these guys, they run a MongoDB-based stack on our cloud, right? So what Adil showed is very much a scale-up, right? Classic RDMS, N-tier web application. This thing is a total scale-out application, right? Mongo plus, they're using a mean stack on top, right? So they chose us again, ultimately, because they were able to get the right price performance for those database nodes, right? Because Mongo has different performance requirements, but it's a super performance intensive application, actually. It's pretty hungry. So they're using our VM dense instances. They felt like they were able to get the right price performance characteristics over every other cloud, and they were able to build their business on it. And it's obviously very cool also to work with smaller companies and startups that are doing this. So